Okay, so now I want to do a little bit of polygon practice with this concept of the formula that you learned for the interior angles, but let's first talk about why this formula works and where this formula comes from. So here we have a whole bunch of different shapes. The first one's a triangle, second one's a quadrilateral, pentagon, and so on and so forth. All these names are based on the number of sides. Triangle has 3 sides. Quadrilateral has 4 sides. And notice that these are irregular polygons, meaning that they're actually not equal sides. They are all different side lengths here. Maybe this pentagon, no, even the pentagon looks like it's got different sides. But so notice that when the number of sides is 3, how many triangles are inside of the triangle? Well, there's just one triangle in a triangle. Now, if I go over here, and by the way, I can't draw any diagonals inside of that, because if I start with this vertex and try to draw a line to another vertex, well, it just makes the side, just makes the other side. There's no way to draw a diagonal through the middle of a triangle. So there's one triangle inside of a triangle. Well, let's go look at the next shape, this quadrilateral. Notice that from this vertex, I could draw a line across to the opposite vertex. And do you see how this time it makes 2 triangles? So inside of a triangle, there was one triangle. Inside of a quadrilateral, there are 2 triangles. So we're going to be drawing in these diagonals here and then filling in this chart below. On a 3-sided figure, triangle, the number of triangles in the figure was 1. And in a 4-sided figure, the number of triangles is 2. And we're going to notice that as we go down this line, there's one more triangle that's able to be drawn in each. Okay, so let's look at the bottom row. How are we going to get this? Bottom row has to do with the number of degrees inside. So number of degrees inside of a triangle, right? Any triangle adds up to 180 degrees. Well, now there's 2 triangles inside the next one. So 2 triangles, 2 times 180. Do you see that that would give us 360? And that's right. 360 sounds right for inside of a quadrilateral. We add another 180. That gives us 540. We add another 180. That gives us 720. We add another 180. That gives us 900. We add another 180. That gives us 1080. Another 180. 1260 plus 180. 1440 plus 180. 1620 plus 180 is 1800. And so we're noticing that it's repeatedly adding 180 because there's another triangle being added every time. How do we show repeated addition? We show that it's 180 multiplying by the number n minus 2, because we're going to take off for the 2 consecutive sides. Notice how we're starting at a time 3 here. So this formula that we're using comes from multiplying those triangles times the number of triangles that are being drawn inside of each shape. So just like we did on our study guide, we know that this 180 represents the degrees inside of a triangle, and we know that the n minus 2 represents the number of triangles inside each shape. So let's go draw in those diagrams here. So how many, actually I'm going to use the straight edge because that just looks sad. Let's do this. So drawing in a diagonal from this sorry guys, shapes. There's our 2 triangles inside. Let's go over to the next shape, a pentagon. Notice I've got 1, 2, 3 triangles that I can draw inside. Next one, 1, 2, 3, 4. Do you see them? Next one, 1, 2, 3, 1, 2, 3, 4, 5. There it is. Next one, 1, 2, 3, 4, 5, 6 triangles inside that one. And there's 8 triangles inside that one. Ooh, get ready on this last one. You ready for it? One, two, three, four, 5, 6, 7, 8, 9, 10 triangles inside of the 12-sided figure. So here's my 1 triangle inside. Here's 1, 2 triangles inside. Okay, and there's my 10 inside of the 12-sided figure. So hopefully your diagonals look pretty on those images. Now, what did we notice? What pattern did we see? We saw that the 180 was adding every time we got to an additional side, and that repeated addition of the 180 can show up in an equation as 180 times the number of triangles. How can we represent the number of triangles formed by the diagonals to figure out the sum of all of them? So if there's a 12-sided figure, we notice that that had 10 triangles inside. Well, why is that? Because the 2 consecutive sides can't be counted. We can't count 2 of the corners because those wouldn't be diagonals. Those are just sides. So we can only count all the other vertices across. So if 2 aren't counted, that's where the n minus 2 comes from. So writing the expression of this, we're always going to use this 180 times the number of triangles, which is our n minus 2. And this is the formula that we're going to use every time we're trying to calculate the sum of the interior angles of a polygon. Now we're going to go practice some of this work. In order to do these questions, we have to know this formula. So notice this first one is a 4-sided figure. 1, 2, 3, 4. So we notice that this is a 4-sided figure, and I need to have that n equals 4 ready when I plug in to solve here. Now, what do I know about all the sum of all these angles? I know that it's equal to 180 times n minus 2. So the sum of all these angles is going to be x plus 3x plus 2x plus 90. All of that adds up to n minus 2 times 180. Well, what is n minus 2? N is 4. So we're going to get 4 minus 2, or 2 times 180, and that equals 360. So you might have already known that inside of a quadrilateral, it equals 360. But in case you didn't, it comes straight from that formula on the right-hand side. Now let's go combine like terms. 1x plus 3x plus 2x's. Do you see that that's going to be 6x plus 90? And now we're going to solve 6x plus 90 is equal to 360 by subtracting 90 from both sides. We're going to get 6x is equal to, is that 150? Oops, 270. And then divide that by 6. We're going to get that x is equal to 45. Now looking back up at what they asked me to do, do you see they just asked for solving for x? So we're done. If they asked for an angle measure, we'd have to keep going, but they just asked us to solve for x. So basically that's what we're doing on this worksheet. We're using this sum of the interior angles formula, and we're adding everything up and equaling it to the number of degrees inside. So do you want to pause the video and try a few of these? Let's see how we do. So this time it's 4x plus 4x plus 92 plus 115 plus 3x. That's all the interior sides. Now, what shape is this? 1, 2, 3, 4, 5. This is the number of sides of 5, or a pentagon. So we know that this is equal, and by the way, you might know that a pentagon is 540, but if you don't have that memorized yet, we're going to set this equal to 180 times the number of sides, 5 minus 2. Well, 5 minus 2 is 3. So 180 times 3 is, dun, 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 there's our 540. Over here, we're going to combine like terms on the right-hand side. We've got 4 plus 4 is 8, plus 3 is 11 x's. And then 92 plus 115. Grab your calculators and add that up. Getting 207. Oops. And now we can solve. Minusing 207 to both sides. Dividing by 11 is giving me 30.27 approximately. Remember when we round that we have to use the approximation symbol. How'd you do on that one? All right, next one are regular polygons, 1, 2, 3, 4, 5. So same, interior angle measure. There's 5 x's. And this is a pentagon again, which is 540 inside. Now, what if you didn't remember the 540? Remember, you could have set that equal to n minus 2 times 180, and your n is 5. Next one is 1, 2, 3, 4, 5, 6. Next one, hexagon. Your number of sides is 6. Well, if you don't remember how much is the sum of the interior angles of a hexagon, remember we can do 6 minus 2 times 180. Do that on your calculator. Did you remember that it was 720, or were you thinking 720? So 720 is equal to 6 y's. Go ahead and divide that and see what you get for. Good job. Did you get 120? Okay, the next one is asking us to solve for x and y. And so let's do the interior angles first, just because we've already been doing that. Notice we're talking about a triangle. A triangle is just 180. We know this. So 3x's is equal to 180. And in fact, this is an equilateral triangle, and I know that all equilaterals have angles of just 60. Now, what about the outside of an equilateral? If it's a 7 out here, isn't all the other sides just equal to 7 as well? And we're done. Next one is 1, 2, 3, 4, 5, 6, another hexagon. We just figured out in number 4 that a hexagon should be equal to 720. But if you don't remember that, just do n minus 2 times 180, and your n is 6. So this is going to be equal to 2x plus, oh man, I'm going to run out of space on this one. Hang on. Let's write smaller. (2x) plus x minus 6 plus 2x plus x minus 6 plus 2x plus x minus 6. All of that is equal to 720. Let's combine like terms. 2 plus 1 is 3, plus 2 is 5, plus 1 is 6, plus 2 is 8, plus 1 is 9. 9 total x's. And then there's a -6, a -6, a -6. 6 times 3, or -18. I'm going to add 18 to both sides and divide by 9. See what you get for that x. Okay. Regular octagon. The interior angle is a 3x. Well, how many interior angles are there in an octagon? There are 8, because there's 8 sides and 8 angles. So here I go doing 8 times the 3x. Well, what's the angle measure of an octagon? You could look back at the chart, but if you don't remember, we can always just fall back on the formula of 180 times n minus 2. And that's 180 times 8 minus 2, or 180 times 6. That gives us 1080 is equal to 24x and you can divide both sides by 24 to solve for that x. All right, this next one has 1, 2, 3, 4, 5, 6, 7, 8 sides. You know what? There's no label on one of these angles over here. So we're going to go ahead and just cross out and skip number 8. Sorry about that, you guys. There's a missing number in my copy. I'm going to jump down to numbers 10 and 11, and I'll explain why, poor number 9, why we skipped it in a second. Okay, number 10, x is the measure of each interior angle of a nonagon. And so picture that there's a 9-sided figure. So let's go see how many, and then that's going to equal an x 9 times because there's 9 little angles. So 9 minus 2 is 7. 7 times 180. Let's see how many that gives us, and then we'll divide it by 9. How'd you do? Did you get 140? Okay, we're also going to skip number 11. So now let's go back and talk about number 9. Number 9 is the one random exterior angle. And the only thing we know about exterior angles that we did in our notes is the exterior angles all add up to 360. So if a regular hexagon has one exterior angle of 2x minus 8, couldn't we say that there were 6 of those same things? So 6 exterior angles of 2x minus 8 all have to add up to 360. So this is the one problem on the whole worksheet that uses our exterior angle theorem. So 6 times 2 distributing gives me 12x. 6 times -8. Add that 48 to both sides. And 360 plus 408. Oops, I gave you the answer. And divide that by 12. How'd you do? Did you get the 34? Okay, so that's just a way to apply that new rule that we just practiced in those notes. Again, this is a Math 1 topic, but this worksheet is a Math 2 level of applying those topics. Okay,